I have been attending DPE for a few years now. Over the course of those years, the topics have varied wildly. In the first year, we focused on build speeds. After that, it was cloud machines and cloud development. After that, it was frameworks and metrics. This year, of course, it's all about AI. Now, over the course of those years, what I've noticed is that one thing has remained constant. And it's not the topics, it's not the speakers, it's the focus. Over all those years, our focus has been on the authoring flow. Today, I'm going to be talking about something that's very dear to my heart. Today, I'm going to be talking about dark matter. My name doesn't matter. No agenda, no bullshit, let's get started. I asked Webster to define dark matter. Webster said, dark matter is the weird stuff that holds galaxies together. So I told my friend Webster that he's a moron, and I instead went to Merriam-Webster and asked for the actual definition. Merriam-Webster says that dark matter is the non-luminous matter, not directly detectable, but hypothesized to exist in order to account for gravitational effects. Now, why am I defining something on stage? This is the most cliche way to start a talk, right? Well, I'm doing that because dark matter is a surprisingly good analogy for a developer's day. Our mental model is that a developer works a full 8-hour day, in fact, codes a full 8-hour day. In fact, our mental model looks something like this. You go in the morning around 9, you get a lot of coding done, you break for lunch, you come back, maybe some emails at the end of the day. Now, quick question for the developers in the room. Have you ever estimated a fix at like a one-liner, 10-second fix, but it took you a day to land it? Actual question. Okay, I see nods. Yeah, me too. And that's because you don't actually get to the change and write it up and call it a day. What ends up happening is, oh, well, let me do that right after my stand-up, right? Or hold on, I got to unblock some coworkers and then I can actually make the change. So we want this to be our mental model, but in reality, a developer's day looks something more like that. You go in the office, you check your chats because that's the first thing that you need to do. You go into your stand-up meeting, talk about what you're about to do. You actually do the thing. You go to lunch, you come back, you do some more things, that's fantastic. But then you have another meeting, then you check your email, and you send some chats. So dark matter consists of all the stuff that holds that coding time together. Dark matter is stand-ups. Dark matter is one-on-one meetings. Dark matter is planning meetings. Dark matter is planning docs. Dark matter is IMs to unblock your coworkers. But you didn't come here for pretty shittily drawn Excalibur drawings, right? You folks came here for data. So let's talk about real data. This is James. Oh, Jesus. This is James's timeline. Now, the first thing you're going to notice is this is a timeline chart, and it starts on July 7th. Now, what's special about July 7th? July 7th is the Monday after July 4th. July 4th was a Friday. This will become relevant in a minute, I swear. So what happened on July 7th is James woke up, he opened his laptop, and he checked his IM. So that bar right there is the time that he spent on his machine. And so if, for example, he spent 2 hours coding in something like VS Code, you would see a much larger bar that is, we'll say, purple or pink in this case. So James woke up around 8. Your first thought should be, well, hold on. Developers don't wake up before 10, so this is fake data. But I assure you, it is in fact real data. So James wakes up at 10. He opens his machine, and I asked him about this, by the way. He opened his machine. Since it was July 7th, he didn't really want to get into work. So what he did is he checked his PTO and was like, well, hold on, should I actually go in the office today? Now, luckily, he decided to, so we'll have more data here shortly. What he ended up doing is he used the bathroom, showered, commuted, and then he gets to the office. Try that one again. So we've established that James is a superhuman engineer that wakes up at 8 a.m. Over the course of his day, he's going to be using a lot of tools. Meta has tens of thousands of tools. Over the course of this day, James specifically used about 50. So he goes in the office, it's about 9:15, opens his laptop. First thing he does is check his chats, make sure that he's not blocking folks. Next thing he does is he checks code reviews. I think we all do that in the morning, right? Who are we blocking? After that, he opens VS Code for a minute, actually does some coding. Fantastic. He's already coding before 10. That actually bodes well for the rest of his day. There are some weird gaps after 10. This is because he's in stand-up meetings. Now, James was not actually paying attention to those meetings, which is why you see those bars there, but he was still there and a little bit distracted. That's okay. He does some work. Fast forward to about 11:45. At 11:45, James and I actually go downstairs and we have lunch. Meta has free food. It was delicious chicken. Speaking of free food, we're hiring. We are right outside. You exit that door, turn left. You'll see a couple folks from Meta. If you have your resume printed out, just drop it over there. If you have a LinkedIn, please share it. Smoke signals, I don't care. Just go. Come back. Not yet. After this, you can go. Come back. All right. So he checks chats. He checks his calendar. He comes back into work at about 1, does some more work. You can see a pretty large chunk over there. He uses a notebook system we have at Meta, just IPython notebook, nothing too special. He finishes his day at about like 5. He heads home. Now, James does a little bit more work, so he keeps checking his jobs that are running. They're long-running jobs. He just wants to make sure that they're working properly. Now, the first thing you might notice is this is very noisy. That gray color that you see throughout the day is not actually a single tool. It's just because the data is so granular that the only thing you can make out is the color gray. But that's not because it's not granular. It's actually because it is granular that this data is very, very difficult to parse. So this data is time by tool. What you might see in my not really an agenda at the top, it's a horizontal line, it's not an agenda, I swear, is that we're starting with time by tool. What we're going to be talking about today is how we can evolve that measurement to capture things that are a little bit more parsable. But before we do that, we're going to be talking a little bit more about how we can use this data to improve our developer productivity tooling. Specifically, this data tells us which tools need to be merged, tells us that a developer, for example, goes from their IDE to the code review tool very often. It might tell us that a developer goes from the high severity event tool over to the code review tool again, really often. And so an example opportunity there would be to connect those two tools so they can skip that jump, especially when you're losing thousands of dollars a second. Now, the most interesting thing about this is it's going to signal the efficiency of our tooling. Now, before we actually continue, I wanted to talk a little bit about privacy. We care a lot about privacy. James agreed to have his data collected and shared to you fine folks. But in reality, you should always be looking at this data in aggregate. And part of it is, of course, we are good human beings. The other aspect is, frankly, self-service. If you were to incentivize anybody to game this data, to game any metric, they would end up gaming that metric. And so it is in your best interest to make sure that you do not incentivize the wrong behaviors. Now, this data is really good for us to understand how our engineers are using the tools. But again, we cannot use it for anything that would incentivize those engineers to change their behavior. The last thing I want to call out is this is James's data, but we have so many different Jameses in our chain that that's actually not identifiable information. Speaking of, if your name is James, we're still hiring. We need to fill up our ranks. All right, I know I said no bullshit, but I have one more bullshit for you. Over the course of this talk, I'm going to mess up. I'm going to say diff instead of PR. I'm going to say creating a diff instead of creating a PR. I'm going to be talking about SEVs. SEVs are high severity events or high severity incidents. I'm going to mess up. So instead of owning my responsibility, I'm going to drop it directly onto your folks' plate. All right, so we're talking about time. As you can imagine, most of our focus will be around velocity metrics. You may remember this talk from last year with Akshay and Kelly. We're going to start by talking about time spent coding per diff. Now, it used to be called time spent coding by diff, and that's actually a hint to its formula. So let's actually take a look at the formula. Time spent coding per diff is really nice and simple. It's time spent coding divided by diff. It sounds very simple, and that simplicity is actually the whole point. The simpler the metric, the easier it is to understand, to move, all of that jazz. Now, in this case, lower is better. We want this number to be lower because this number is effectively how much does it cost, time-wise, to land a diff at Meta. The numerator is time spent coding. This is all of the time that an engineer spends on coding or coding-related tools. This could be the IDE. This could be the code review tool. This could be an experimentation tool to launch your feature to 50 million people. This could even be an on-call tool or an alerting tool, right? Denominator or denumerator, as I called it yesterday, the denominator is number of diffs, simply the output that your engineers are producing. Now, this metric is meant to tell us how efficient it is to code at Meta. Y'all are pretty smart, but I'm still going to walk through a concrete example for you. Let's take one developer. Our first developer spends about an hour and lands a single diff. Our second developer spends about 90 minutes and lands 2 diffs. Third developer, about an hour, also 2 diffs. And the final developer, this fourth developer, spends an hour and lands 8 diffs. Now, I want what that developer's on. That's a different problem. So if you do all the math, what you'll find is that TSD for this group of developers, again, you always want to look in aggregate. TSD for this group of developers is just under 21 minutes. Now, obviously, this data is fake. We don't have any engineers that produce less than 20 diffs a day. I'm not going to tell you the real number. I'm sorry. I'm not even going to tell you what we goal on year over year. What I will tell you is a couple examples for how to improve it. Now, I'm getting you ready. If you want to take a picture of the QR code, which will show up shortly, get your phones handy. Now, the first thing I'm going to be talking about is my personal favorite thing. If you were here last year, you've probably heard about it. The second thing I'm going to talk about is something you've definitely heard of. You may not have heard in this context. The first is simple. It's autofocus. What Meta has done in the past is launch a tool called autofocus. What autofocus does is it mutes an engineer's notifications while that engineer is coding. Now, of course, it warns the sender that those notifications are muted because that would be problematic otherwise. And in fact, it allows the sender to override those notifications if they choose to. All they have to do is put a little @notify tag. Now, we have a paper on it that explains exactly how much focus time our engineers were able to gain from this. So again, I saw a lot of phones. You had your chance. The second example I want to talk about is a bit of a nod to our wonderful hosts here in Gradle, is build latency. What we've noticed is that improving build latency makes it more efficient to land diffs at Meta. Now, that's probably obvious, but the interesting reason, or the interesting thing is how. I'm actually not going to tell you, but if you folks have ideas, I'd love to hear during Q&A. Why does build latency reduction improve our developers' efficiency? Now, I personally hate subjective data. I'm really sorry. I just made none of half the room. I hate subjective data, but we also found that a metric like TSD was highly correlated with how efficient developers feel day to day, which is reassurance to me that the metric is measuring the right thing. All right, so we talked about TSD. This is an efficiency metric. It's used for infrastructure teams to improve the efficiency of their tooling. Makes sense. It's great for measuring efficiency while you're coding, but it's not necessarily very good at measuring the non-coding work. So let's go back to James. Last time we talked about the noise in a developer's day. This is another example timeline. Now, when a developer goes from tool to tool, again, when you're measuring it by tool, it looks very noisy. But what we've realized is that a developer always has a specific intent in mind. That word's going to be key here momentarily. They always have some goal that they're marching towards. Let's take the first half of the day here. Developer opens VS Code. They go to their chats. They're actually asking a coworker, how do I write this thing? A for loop in Python, I forget, help me out. They go to SQL. They're like, you know what? I'm going to write my for loop in SQL because I hate my life. They go back to chat. They're like, hey, I figured it out. Back to VS Code, they actually write their change. Now, over the course of all that time, they used a bunch of different tools, but they had a single intent, and that was to author whatever the change that they're trying to author is. Same example over there. Engineer opens up the wiki, starts making some edits. They have to go to VS Code to take a look at the code that they're trying to document. So again, they used 3 tools there, but again, their intent was documentation. So what we end up doing is we try to remove as much of that noise as possible. Because again, if you look at the detailed tools, they're all over the place. But if you generate an algorithm that looks at the frequency of tool usage and the patterns and the transitions, what you end up getting is something like that. In the first half of the day, the engineer was coding. In the second half of the day, the engineer was writing documentation. Now, again, you didn't come here for shittily drawn Excalibur, so let's look at how this data looks in practice. We already looked at by tool. Now we're going to make it less noisy. We're going to be looking at by intent. So as you can see, it's a lot easier to parse, right? You can see in the morning, James checked his IMs, right? That's the orange chat box over there. A little bit later in the day, he opened up an IDE. His intent was to code. And then he went to his stand-up, and obviously that was a more collaborative workflow. After lunch, he logged on, checked his IMs, make sure he wasn't missing anything, and they went right back into coding. You can actually see all the time that this engineer coded in the afternoon. It's a lot more interesting. So this right here is why we're actually here. These coding blocks clearly do not span the entire day. This tells me that a developer's workflow has a lot of overhead in it. They're not able to code for the entire day. So now that we have clear data, how do we use this? We can't just look at individuals. That's the wrong thing to do. So let's go back to our framework and look at another metric called percent time coding. Percent time coding, unlike TSD, is meant to measure the amount of overhead that engineers run into on a daily basis. Percent time coding is also very simple. Percent time coding is the coding intent, not time, the coding intent divided by all the other intents. The goal of this metric, of course, quick reminder, is not to look at individuals. The goal is to nudge the right behaviors to modify the processes that your business has. Now, again, I don't love sentiment. Rather, I don't love subjective data. Let's do that one again. But what we also found is that PCT is correlated with how much overhead a developer feels they have in their day-to-day. While TSD is good for infrastructure teams, PCT is really good for product groups. PGs won't really improve dev tooling. What they will do instead is they'll identify, oh, you know what? We have too many product groups. Sorry, don't try again. We have too many stand-up meetings. We have too many syncs. All right, so same deal. Sorry, not sorry. I'm not going to tell you the actual number here. I'm also not going to tell you what we goal on a year-over-year basis. What I will tell you is a single thing that you can do today to improve something like this. It's really simple. It's focus time. You've heard about this before. In any given organization, the communication overhead scales quadratically with the size of that organization, which makes sense. You have 20 people. Now you probably need to chat with the majority of them to figure out what you're doing. Let's take a look at my boss's calendar. I'm sorry, boss. This is pretty terrible. It's not even time to eat, right? This sucks. But this is actually just about the same as this to an engineer. It doesn't look like a lot of meetings. In fact, it's 4. But the problem with this is it disrupts the engineer's flow. It prevents them from actually being able to sit down, get in the flow, and stay in that flow for as long as they need to land the change they're working on. The solution's really simple, however. Coordinate your focus. Again, if there's one thing that you do when you get back, create these focus blocks for your engineers. It makes a massive difference in how much time they have to focus on the work that they enjoy doing. All right, now the whole talk is about dark matter. It'd be really weird if we didn't actually talk about the dark matter itself instead of all the other stuff. So we talked about how overhead is dominated by meetings, chats, docs, all of that stuff. Let's take a look at meetings. In order to improve PCT, we did some analysis and we figured out what folks are spending time on during these meetings. Now, these numbers are, of course, arbitrary. There are about 5 here. In reality, there are dozens of different types of meetings that engineers have with each other, with XFN, etc. This pie chart shows one-on-ones, for example, take up the majority of time, followed by planning meetings. These are meetings where you are making sure that the direction that your team, group, individuals are heading towards is the right one. Stand-up meetings, of course, we all know and dread those. maybe some DevOps related meetings. You're dealing with a high severity incident, whatever it is, security, updating packages, whatever it may be. So what does this tell us? This tells us that folks spend a lot of time in stand-ups. What's the solution? Well, the solution might be reduce the frequency or reduce the time. Maybe instead of 30 minutes, it should be 15 minutes. Instead of every week, maybe it's every 2 weeks for a one-on-one, for example. Now, to get to this stage, we have to talk about something that we don't quite have time to talk about. Unfortunately, relatively difficult. You're going to have to solve for meeting attendance. What does attending a meeting, what is that defined by? Is it accepting a meeting? Are you definitely there if you accepted it? Or are you definitely not there if you were marked as tentative? That's a harder problem. If you're very curious, ask me in Q&A or drop on over. I'm here all day. All right, so we talked about meetings. What about docs? So it's going to be the same problem, just a little bit of a different flavor. Again, this pie chart, I'm sorry, it's a pie chart. This pie chart has 6 categories, but again, in reality, it's dozens. This shows that engineers spend a lot of time on design docs, that they write reports to leadership, they write product briefs. It's a fantastic thing. Maybe they work on their own career docs, notes, whatever it may be. Now, same deal, the way that you would solve this is perhaps create templates for your junior engineers to make design doc authoring easier. How many folks here have at some point created a design doc template in their careers? Yeah. The fact that we all have to redo that every time, kind of indicative of the problem. All right, so summarizing a little bit here in my not agenda, we talked about time broken down by tool. We talked about time broken down by intent. But there's another need. By tool is fantastic for infrastructure teams. By intent is fantastic for product groups. But what about those teams that need a little bit more detail, need to understand specific workflows? The team that improves high severity events management, for example, or the team that launches experimentation tools, or the team that works on deployment tools. They need to know how easy it is to use their tool. But they also can't look at just all of the time spent by tool. That's incredibly noisy and doesn't give us any value. Enter WTS, workflow time spent. Now, time is in the name. I'm sorry, I did warn you. This talk is about time. You have no one to blame other than yourself. WTS is a framework that consists of 3 steps, A, B, and C. We're going to look at an example first. This over here is a timeline for a single engineer. Now, that engineer opened, for example, the SEV tool, which for us, again, is an incident management tool. So they opened up this tool, maybe they modified the title. After that, they opened up the same tool, maybe they left a comment. After that, they opened up a Google Doc, take some notes about the high severity event. Then I am their manager. Well, hold on, I think I've solved this. I'm gonna author a diff for it. Now they open a diff, see I messed it up. Now they open a diff and they make their change, they update the task that they're tracking it in Jira. Now, what we do after that is we assign each of these events to the workflow, in this case, the SEV number, we'll call it S123. And we do that for all of the events on this timeline. You do it for the SEV tool, that's nice and easy. You do it for the doc, it's a lot harder, but still possible. You do it for chat, you do it for the diff, you do it for the tasks. Nice and simple. Now, once you have that, what you do is you create calendar windows. Now, those calendar windows you only create if 2 events are within 15 minutes of each other. Now, that gives you calendar time. That in and of itself is not very valuable because I could be checking the SEV, walking away to do something else, coming back to check the SEV again. That doesn't necessarily tell us that the development flow is poor for a given tool. So what we do after that is we take those calendar windows and we fill them in with time by tool. Now, the magic of this is it now tells you that over the course of resolving this specific event, you know exactly what tools the engineers used. You know exactly what transitions they need you to fix to improve the tool. So this is time by workflow. We're talking about SEVs. You can inject any other workflow that you care to. So again, you folks are not here for Excalidraws. Let's look at real data. This is a specific high severity event. Now, this is a timeline over the course of 3 days. You can see the grouping here. The y-axis is a single person. So person number 16, of course, anonymous data. Person number 16 opens the SEV. This is the manager of the team. So they create the SEV and they ask their on-call to take a look at it. Their on-call is actually a new hire. He takes a look. They assume it's a pretty low severity event. He starts to deal with it throughout the day. He gets to the end of the day. He doesn't quite have a clear solution. His manager takes a look at it and realizes, hold up, this is actually a much larger issue than I realized. Now, it's not large enough to wake people up, but it is large enough to deal with at a relatively high priority. So the next morning, he asks the entire team to swarm on it, and you can see that. You can see all of their workflows over time. Now, they go through the first day, they identify the problem, they launch it the second day, they fix it. Fantastic. What WTS allows you to do is measure that and identify where the bottlenecks are, whether it's process, whether it's tooling. Again, get your QR codes, get your camera phones ready for a QR code. I just call it camera phone. I'm not old. Get your phones ready for a QR code. We end up using this data for things like SevMaze. This is an AI agent that accelerates Sev resolution. It watches the diffs that folks are looking at and understands which ones are the root cause and starts proposing them as more context comes into the picture. Now, we only talked about Sevs, but in reality, of course, these workflows are extendable to on-call burden or wiki authoring or diff authoring time. All right, so summarizing a bit, today we talked about Meta's journey throughout time-based metrics. We talked about TSD, which is fantastic for infrastructure teams. We talked about PCT, which is fantastic for product groups. We talked about WTS, fantastic for very specialized teams. But as you can see from my spoiler at the top, there's a fourth one. Let's talk about that. Now, all these metrics are designed for a system where we only control the technical tools. And I think that's what most of our focus has been around, right? We focus on the tooling that we control, which tends to be IDEs, high severity incident management tools, code review tools, all of that jazz. But there is very, very, very quickly coming a time where we can actually influence a lot more of that time. With AI, you can improve meetings. You can start to prompt folks who are veering off topic. You can start to summarize chats so they log onto their machine and they don't waste as much time catching up to the data that they have to catch up on. So that brings me to the last time measurement pattern, which is by value. And when I say by value, I mean by business value specifically. Now, the easiest way for me to explain this is with a biking analogy. So let's actually talk about that. We want to break time up by the business value that it provides. How much of your time is spent on core work? This is time that is furthering business goals. This is equivalent to pedaling, right? You're working on a feature. You're working on a new piece of infra capability, right? Which is very separate from the acceleration that you do. I'm sure folks here have worked on refactors to make it easier, reduce code complexity, right? That, in my mind, is equivalent to the maintenance that you do on your bike. This, again, is different from friction. These are bugs. You have to fix them. These are high severity events. You have to deal with them. But they don't directly provide business value. And the last bucket here is direction. At some point, you got to stop your bike. You got to pull out your map and you got to figure out, where am I going? Are we still on track? Are we doing the right thing? Now, if your name is Pavel, you'll recognize that this analogy is wrong for 13 reasons, but just gloss over that fact. And if you're curious about the whys, we can chat later. Speaking of Pavel, we have some wonderful talks today. Pavel and Payam will be speaking at 5 today about how we're measuring the impact of AI on productivity. Now, I can't call out all the fantastic names of fantastic folks here today. Olga, Max, Brian, Aubrey, I can keep going, but I can't. So instead, stay tuned, come on over. It'll be a very fun one. All right, that's all I've got for today. And lastly, final note, as always, my self-worth is based purely on how loud you applaud. So please build me up.